So in this video we're going to establish the standard unit normal vectors for the plane. The standard normal unit vectors for the plane, which is also denoted as R2 or R cross R, or two-dimensional space, or the Cartesian coordinate plane. The standard unit normal vectors are defined to be the vector I, which is the vector 1, 0, and the vector j, which is the vector 0, 1. And the thing to notice is that those two vectors are the vectors of length 1 that lie on, let's see if I can change the color here. Ink color, let's go black. So they're the vectors of length 1 that lie on the x and the y axes. So right here would be the point 0, 1, and down here would be the point 1, 0. So the standard normal unit vectors for the plane are the vectors 0, 1, and 1, 0 that lie on the x and the y axes in the plane. They're unit vectors because they are each length 1. They are normal because they meet at a 90-degree angle, or another way of saying that, they are orthogonal to each other. They are orthogonal. Normal means meets at a 90-degree angle, orthogonal, 90 degrees, perpendicular, kind of used synonymously. And the key with the standard unit normal vectors, if we have any vector u that's equal to u sub 1, u sub 2, we can easily express u using the standard unit normal vectors like this. We can say u can also be written as u sub 1 times I plus u sub 2 times j. And we can verify that this is correct just by thinking about the vectors that I and j represent. So this would mean u sub I times the vector 1, 0 plus u sub 2 times the vector 1, 0. Sorry, 0, 1. I don't know why I wrote that. I was thinking about something and my brain just flitted. So this is a scalar now. The components of a vector are just real numbers, so we can distribute that scalar in. U sub I 0 plus 0 u sub 2. And then we know how to sum vectors. We take the sum of corresponding components. We get u sub 1 plus 0 is u sub 1. And 0 plus u sub 2 is u sub 2. So you can see we get back the vector u that we started with. So if we had a vector, for example, 5, 6, we could also describe this vector by going 5i plus 6j. So this gives us a different way to express vectors, and sometimes this will have advantages over this format and vice versa. So usually you use the format that works best for the application that you're doing.